Okay, so now we should be recording, and I'm going to start the presentation by sharing my screen. Should be able to see my PowerPoint now, hopefully. I'm going to go to full screen. I forgot how to do that. Slideshow. There we go. Okay, so you should be able to see the title screen now. So basically, as I said before, this workshop is going to be anything you could ever want to know about 3D printing. I'll go into some details about, what that is, why you should care about it, and just any other details you could ask. The reason I made this, I personally have a big interest in 3D printing. I think there are a lot of, great uses. I think there's a lot of cool things you can do with it, especially in the field of robotics. And as I said in the email, from personal experience, I've been printing for about 4 to 5 years now, I think, coming up on it. It's been a great experience. And yeah, I want to pass that knowledge on to others. Okay, so to start, if this is your first time the workshop, I won't go all the way through these kind of introductory slides, but just, just give a little basis of what we're doing. If you haven't been here before, the basis of this series and why this is the third workshop of a series, basis of what we're doing is that we want to teach students anything they could possibly want to learn about robotics and like the introductories to robotics so that they will have skills that allow them to, build things, design things, code things, and anything you want to know. And so for some students, they have background and they've done some of this stuff before, but for others, they come to college, they've never done this stuff before, and it helps, to have something, that introduction material so they can learn something earlier on. So as I said here, we're doing this because we want to teach you guys, we want you guys to, learn stuff, and, just overall be more knowledgeable about some of the topics we're going to cover. Beforehand, I covered CAD one, and then my friend Fran, she went through a workshop about how to actually CAD. Mine was more like everything, like the more theoretical side of CAD. And also, this is a little more, not self-interested, it's a net positive, but once you learn these skills, it is more useful when you join, for the club, this is for Cura Robotics, when you join us and want to join one of the teams, you'll have more skills that you can pass along and use in our time, basically. So the next point is who's going to be teaching this. This is everyone that are teaching the workshops. Benen's going to be covering a lot of the computer science segments. That's going to be next week. So it's going to be, there's 3 computer science segments. They start next week and they run for that long. Fran covered the how to CAD one. I did intro to CAD and now I'm doing 3D printing. And then this other guy, Sam Treese, he's an alumni. He helped make a lot of the computer science ones. So big thanks to him. You might see him in office hours or something. Okay, so what are we actually making? And this is, this is the design part of things, and this is the 3D printing part of things. You'll see on the left is a rendering of the rendering of the arm in CAD. So what that means, we made it in CAD, we designed it, all this stuff, and we took a nice picture of it, basically. On the right is the actual thing printed, and that's actually printed on my printer at home. I'm an online student, and so I brought those to Bennett, who put them together, and that's the actual picture of it. So the idea that, just a small example of, you can come up with an idea and bring it into reality. Okay, and I think this is the last slide with like the content of the rest of the workshops. We're covering, we covered CAD, we're gonna cover 3D printing today, and then the rest of the stuff, all the computer science stuff to the right is this is all like programming in Python, A-star planning, forward kinematics. And so if you're interested in like the computer science side of things, that will be the next 3 weeks. And there's all the information you want on our website and other platforms. Okay, so now I'm going to resume with 3D printing content. So I'm gonna go through this like in chapters basically, and in every chapter I'll say, hey, does anyone have any questions? And then we can go on from there. Okay, let's start off. So you may ask yourself, what is 3D printing? You may not have heard of it. You may have years of experience. I'm not entirely sure. But as a basis, 3D printing is a type of additive manufacturing. You may ask, what is that? Well, if you think of anything else, or how we make a lot of other things, that's typically subtractive manufacturing. So what that means is you start off with something like a block of material, and you remove little pieces of it until you get what you want. So let's say, you have a tree, you cut away at it and you remove the bark, you cut into pieces, and then you can get like boards, like 2x4s. That's how you like subtractively manufacture something. You could have something where, there's a lot of examples of subtractive manufacturing in our day-to-day lives of how stuff is made. There's also something called additive manufacturing. What that means is you start with little pieces and you build something bigger. So in a very general sense, like if you were to make something out of like clay, you're like starting off with like this kind of clay off to the side, and you're like, I guess you could remove stuff as well, but you could add stuff together and build something like a physical object out of smaller pieces. You could actually, would be a good example, a sandcastle. Sandcastle would be additive manufacturing. You're adding pieces of like the castle until you get the final result. That's a very simple idea of, simple example of that, but the implications is, there's different situations for each type of manufacturing. So one of the great things about, and why part of the reason why I love 3D printing is that, when you remove material from something, you start off with something, you're going to have waste product. That shaving, when you take that, log and you make it into planks, you're having that, the outside material, whatever, there's going to be waste. Theoretically, if you do the additive manufacturing, you're going to have relatively low waste. And you can create more complicated objects because you're starting with smaller pieces. It's kind of like, building Legos or anything like that. You can build each tiny piece up until you get the final thing. Okay, so next slide is, so on to 3D printing. 3D printing in itself is a relatively new technology. It was started around the 80s. And when you think of 3D printing, other things have been going on for, centuries. But in terms of manufacturing, these are like the different types of 3D printing that you'll see. So there's three main types. There's FDM/FFF, there's SLS, and there's SLA DLP. As I said, with the infamous 3D printing triangle, these are like the main three. There's other sub-branches, but they're really not as popular. Okay, so FDM. When you think of FDM, or sorry, if you've ever seen a 3D printer, or if you know what a 3D printer is, ever seen it, it's most likely an FDM. Basically, what an FDM is and what it stands for, it's fused deposition modeling, also known as fused filament fabrication. No one ever really says out like the long form of that. But basically, what happens is you take plastic filament, and when I say plastic filament, it's basically this long, it's this spool of plastic, like, I guess when I say filament, it's like this long rod, but it's like curved and it can bend. And so what you do is you take this plastic and you melt it. And you melt it in a way that it like in lines, and you create an object layer by layer. And so what that means is like you're taking like this like kind of line of something and you're making a 3D object. And the way you're doing that is by like putting plastic in different places. I'll explain more into like how layers work later, but that's the basis. This is melting plastic. What's great about this is it's low expense, it's relatively easy to use, and you can make really big things very easily. And same thing, this is what most people picture a 3D printer is, if you've ever seen one or used one. Okay, the next type is SLA DLP. So this is actually the first type of 3D printing technology, like the modern ones ever made. Basically what you do is you take this like resin it's I forget what it's called. So it's photosensitive resin basically. Basically what that means is if you expose it to UV light, it gets hard. The resin hardens, which sounds kind of like odd, but it's actually really useful because what you can do is you can create objects that way. And what that does basically, and what you'll find with these printers is you have like a vat of this liquid that I was just talking about, and you'll shine a laser at it, and that laser, like, it basically hardens the material on a layer. I guess I'll give a better explanation of just general 3D printing real quick. 3D printing works on a layer by layer basis. So what that means is you make one layer and then you move up a little bit. And then you make another layer and you move up a little bit. And you make a layer and then you move up a little bit. It's like if you were to like take an object and cut it into all these little tiny pieces. So let's say you had a knife that could cut like that. You'd have like all these little different layers. And so you're creating the object layer by layer by like stacking them on top of each other, like all these little plates. And so in this method, you cure these layers with light using this thing. The third type of printing, the main types, is something called SLS, which is selective laser sintering. Basically what this means is how about this? The first thing that you need to know is this is how you typically make metal parts. So if you ever want to like 3D print a metal part, it will typically be made using SLS. And what that is you have like this metal powder typically. It can be, different types of metals. And same thing, you're going to shoot this. This is a much more powerful laser. This laser will go across this like powder or go across this like container of metal powder. And because it's so hot, it melts the powder together into a piece. And so what it does is it does that first layer, and then a roller pushes more like of this metal dust on top, and then you melt the next layer of the metal. And so you go layer by layer until you get a part. So like one on the right you'll see is like that gear. And same thing, what you could do is, make these really complex designs and not have to go and like use all these different machines to make it. Instead, you can just 3D print it on metal. It's really cool. It's a little more industrial, so you can't just go into your house and have a metal printer. It'd be very difficult because of how hot that laser is that I was talking about, and like safety and all that. But it's still very, very cool. Okay, so I made this chart, which basically kind of summarized what I said in more concise manner. And just so, a general note of these things to better understand them, as you see, FDM, FFM, you're taking a roll of plastic, you're melting it with a hot extruder, and then you have your 3D object. And so you can go tomorrow and buy this printer, and you can get ones for like, one I have is around, I think I got it for around like $215. Which is, in comparison to a lot of other things, it is, a pretty good deal. And like in terms of like, if you were to buy like any other types of machine that could build things, it is a very good deal. And so what's great is, people just regular can just go and print with general ease per se. We have a few of these printers on campus, which is really nice. I'll go into more detail with that later, but you could go out and buy one today. Same thing with SLA DLP, that is becoming more popular. That's what I was talking about with the light curing resin. So same thing, you're shining this laser at this vat of liquid, and then you do a layer, you raise it, and you do another layer, and you have an object at the end. And so with that, you'll be creating more highly detailed models, because instead of this big thing moving around and like extruding plastic that's a certain width, it's instead a very, very, very tiny laser that can do all these precise movements and do all this stuff. Sorry, not precise movements. It has a very, very small like diameter of the laser, and you can also create very complex parts. So the third one, same thing. SLS is the metal powder. So same thing. You're having that laser. You're melting each layer of powder, and then you're going up a little bit and doing the next layer, going up a little bit, doing the next layer. And so, yeah, same thing, they all have their uses. SLS is more industrial, and yeah. Oh, I have a chat. I will read it. SLA using also scales a bit better than other methods, and it makes parts. You can print the entire area of the output screen at the same time. Oh, yes, yes, yes. That is a very good point. Thank you, Daniel. So yes, the great thing about SLA is that if you have a large object, it will print, sorry, it doesn't matter how large your object is on an SLA printer in terms of layer by layer, because with DLP, so I should have went into more detail with this. The new technology is called DLP. So what that does is like you take like a screen, like let's say like a laptop screen, the same kind of idea, and you can choose what the layer is going to look like. So instead of one laser, it's like, you know, the entire screen is a laser per se, and it can cure in big shapes. So with every other type of printing, it takes a while because you have to actually go around and draw out the shape and, you know, actually fill in the shape and do all these different things. With DLP, you can cure an entire huge layer in like a second. Like it doesn't matter how small or large that layer, like how wide that cross section is, it will cure the same time, which makes, you can make very big things, you can scale them up very easily, which is very nice. Well, thank you, Daniel. Okay, so the whole reason I got into this, and you know why I'm presenting this now, is that within the last 10 years, there's been a huge growth in the popularity of desktop printers. So I was talking about earlier, you can't really get that the metal printer for your house just yet. However, you can get the plastic printer, you can get the resin printer for your house, you know, tomorrow, which is really great because, you know, it allows a lot of people to work on projects they wouldn't have been able to have access to before. That's how I got into it. About, as I say, about 4 years ago, I got a printer for Christmas. I started messing with it, and you know, that's where I'm here now. Is a lot of times working with things and, you know, trying to figure stuff out. And right now, you know, FDM is more widespread. So that's a plastic one. It's much more widespread, and you know, at the moment, it's more economical if you want, like, if you want to print something really big, you know, it's cheaper. Oh, sorry, that's why I'm shows this. SLA printers are typically more expensive if you really want a good one, compared to, you can get a pretty good FDM for less money. That is just because, you know, the FDMs, the plastic ones, are just a little bit more developed at the moment. However, there is, you know, there's changes in technology and things are getting, you know, cheaper to make. So, you know, it's good. So let me just think. What's the next thing? Oh, so I have the pros and cons. Okay, so these are comparisons of two different printers. They're a little bit different. They're in different leagues in retrospect now, because I was saying before, the Prusa Mark III is around $1,000, and I believe the Formlabs 3 is like a couple $1,000s. I'm not exactly sure. Still, you know, they're both, no matter the price, they're both amazing printers. And I kind of go through what I said before, and same thing here. Is with the FDM, you can get a lot more high strength parts more easily. You can do a lot of materials. You can do, oh, that's a very good point. I'll bring that up. Thank you, Daniel. The large print volume. So if you want to make a big object, it's really easy. Versus, you know, with SLA printers right now, just because of technology, they're typically smaller print volumes. That's like basically how much of something you can print, like how big it can be. The cons, you know, the FDM, what's better is, sorry, with FDM that's worse is you get lower, you can only hit a certain amount of detail. You know, with SLA, you can go pretty precise and make like these, like just art pieces and just like these incredibly complex things that you wouldn't be able to even imagine with FDM. So there are restrictions with that. And as I said here, the FDM, as your parts, as that cross section of the part grows bigger and bigger, it's going to take more and more time to make that part. But with SLA, it's, you know, it can be as big as, it can take up the entire space in a 2D sense, and it will take the same amount of time if it's very small. And what else should I say? Oh, so SLA is typically lower part strength, so it's typically not as strong. That's why you see, you know, that's part of the reason why FDM is so popular, is that, you know, the parts you make are pretty strong, depending on the material you use, and you can use them functionally very easily. You also need to cure the part before it's ready for use. I should have mentioned this earlier. I didn't say it, but it was in the slides. But once you're done making your part in SLA with it using SLA printer or DLP printer, you need to cure it with a UV lamp or like the sun. Basically what that means is that you need to put light on it one last time to make sure it like hardens completely. Otherwise it will start to kind of deform and all these different kind of problems. So you just need to make sure you do that first. And the other good point that Daniel brought up is that there are health risks associated with SLA and DLP if you're not careful. That the resin isn't, you know, healthy to, you know, with the fumes and other things. So you need to be careful when processing that and doing cleanup and all these different things. So, you know, to get into SLA it's definitely a more difficult task, and you have to be much safer. With FDM, you still have to be safe, because what I was saying about the melting of plastic, the end of the printer, the nozzle, what it's called, is like really, really hot. It's like 200, and it can go up to like typically it'll be like 200, 250 degrees Celsius, which is incredibly hot. So you have to be very careful with that. And if you use certain filaments, there's also like fumes that come up. However, if you use, which is my personal favorite, if you use PLA, which I'll go into more detail later, it won't create those fumes, so you'll be, you know, mostly safe. You still always want to have a fan running, but it's much safer. Yeah. Okay, does anyone have any questions? I know that was a lot. But yeah, now would be a good time to ask. If you have anything in chat, or you can unmute yourself and just ask. Okay, if that is the case, I will move forward. Try to be concise and don't want to go over too much this time around. Okay, so uses of printing. There are many. I think that, you know, I personally hold the belief that, you know, there's a lot of things that you can, there's a lot of problems you can solve with a 3D printer in terms of like design and all these kind of things. So one of the biggest things is hobby printing. That's something that I take up a lot. And what that means is, you know, someone gets a printer for their house and they just go and they make things that, you know, they look cool, or they fix some problem in their life, or, you know, they're prototyping something and, you know, they want to see how it looks. I've used that many occasions. I design things, I want to see a prototype of them. I, you know, send it to my printer, I print it and see how it feels in the hand. Or if I see like a cool art piece or like a cool vase. I've gotten so many presents for like my parents for like different events, for like, hey, you know, I made this vase for you or whatever. So it's a really cool use. Manufacturing is a big thing. So same thing. 3D printing has been around for a long time. I think, as I was saying, in the past 10 years, I think it's expanded a lot. And same thing I was talking about here is that there is a lot of market share that is dedicated to these like they're really expensive printers. There's like hundreds of thousands of dollars, but they're like saving the company, you know, that or even more in terms of like revenue making parts. Because, you know, the other biggest form of making plastic parts, if I'm not wrong, is injection molding. And for a lot of uses, you know, injection molding is great. The one use that, you know, not as good is, you know, if something changes, then you have to change the molds. And you have to do all this, you know, other process to get that to work. But if you are just changing your part, you can just print new parts. And so a very simple idea, but like it can save you a lot of time and money to not have to like go and to like change the molds for all these different things. There's still lots of cases where injection molding is better for plastics, but there are lots of cases for 3D printing works better. Yeah, and they create more product in-house. So you don't have to have these objects shipped to you. You can just buy the filament and print whatever pieces you need in your company. Okay, the third biggest use is medical fields. So retainers is a big thing. People have like made like really cool objects and things to help with medical field. The functional 3D printed prosthetic hands and legs and arms. I'm personally very interested in that. And because one of the projects I'm on here is Your Hand Project, which that's actually our goal, is to make a 3D printed robotic hand. So if you're interested in that, you can definitely reach out to me about that as well. And there's something called bioprinting, which is you print like cells, which sounds weird, but it's basically you could like print an organ per se, or like a tissue or anything like that. And there's a lot of future for that. Oh, also the cool thing is that you may have seen this at some point, but for some places, local maker spaces have been dedicating a lot of their time and efforts to make like respirator masks, which has been a really great use. People basically come together and they take their printers and they make as many masks as they can and they send them off to go for people to use. I personally was trying to do that over the summer. It wasn't as successful because some people, there's some design constraints I had to come around, but the idea is that, you can use your printer to help others, and I think that's pretty cool. Prototyping is also a great use. What I was talking about earlier, I've used my printer so many times to prototype things and come up with, whatever I felt like creating that day, or not creating that day. That's also, you can come up with a design and say, hey, I want a quick model of it. I want it printed. And you can do that in a day. But also, there's things I've been working on for months that I could actually go and print and see how they work and make sure it's all good and all that. I'll bring this up on camera really quick. I love to show this off because I am proud of it. If you'll be able to see in the thing. One of the things I worked on, you may have seen this at some point, is the 3D printed hand. I won't go into the functionality because it's way too long. But just the idea that I printed this on my printer at home, and I think it took in total, I'm not sure how many hours, but a certain number of hours, and I had that, and I could actually physically test it and mess around with it and all this stuff, which is great. And yeah, there's a lot of promise for that. Does anyone have any questions after that section? I will take that as a no, and I will go on to the next section. Okay, so this is like printing 101, as I said here. This is like you physically going out and be like, hey, I actually want to go and print stuff. And like, what do you need to know? So there's a lot of popular desktop 3D printers. This is a very, very short list. That does not cover everything. But these are like some, pretty well-known printers that people seem to like. I personally have a Creality Ender 3 Pro. There's something, so on that same kind of level, there's something called the Eligo Mars, which is that SLA DLP thing I was talking about earlier. That is one of those printers. And it's in the same price range, which is really nice. There's something a little nicer called the Prusa Mark III. Prusa is a really reputable brand for 3D printing. People really like them. Really quality parts and, good customer service, all this stuff. Great. Formlabs Form 3. Formlabs is like probably for, it is definitely more expensive, but it is like the best SLA printer you could want or need. It has a great build volume, great quality, all this stuff. So yeah, these are probably the best of the best per se. MakerBot, people really like the replicators, really quality printer. And then the Ultimakers, people really like as well. Same thing. They're all great printers. You know, the price tags can be intimidating, definitely. For the Ender 3 Pro and Elgo Mars, I think they're great beginners options if anyone really had any interest. Other ones are more, you know, if you're saving for a small business or college or anything like that. I mean, you could even argue if you get into the intermediate stage or more advanced stages, you might want to put some more money into a printer because, you know, you'll result in much better. You'll be able to like create a whole new level of parts and all these different things and of quality on that. Okay, so now I'm going to talk about relatively quickly the popular filaments for FDM printers. So FDM, just a reminder, is where you melt the plastic and you make the part out of layers of this plastic melted on top of each other. For the SLA DLP, they use resins. I don't cover resins in this workshop, but there's a lot of great resins out there. Most likely you'll be working with FDM printer in your years, so I just wanted to cover this first per se. Okay, so my first and most favorite, or not most favorite, it is my most favorite filament is something called PLA. It's probably one of the most popular filaments. Why I love it, it's environmentally friendly. It's made from cornstarch actually, in most regions, it's made from cornstarch. It depends on where you're buying it from, what it's physically made of, but it's usually made of something that is like some bio material. It's very easy to print with, and it has low to medium strength. What I was talking about before, you'll want to, anytime you're printing a material, it has certain temperatures it likes to work at, so it like prints the best, because typically when you buy the filament, it's just like hard string that goes around this like roll, and like it won't do anything at that point. So you have to heat it up to get it like really melting so that it bonds with the other layers and it's like ready to be like molded, and you do all this stuff with it. The bed temperature, so FDM printers have a bed, I should have mentioned this earlier. They have a bed that heats up, and the reason the bed heats up is because it allows for the first layer of the plastic to adhere better to the bottom. So you want that. It makes things much harder if you don't have the heated bed. And for PLA, you typically like to do 60 to 70. You can do it unheated. It's probably not the best, but you can do it for PLA. Next one, ABS. This is like maybe the most popular filament for FDMs. It's very strong. It prints higher temperatures of PLA. You'll see 230 to 240, and bed temp is 100 to 110. You'll see for PLA, I forgot to mention that PLA is like 195 to 215. So it is petroleum based. Same thing. I'm very much like a environmentalist thing, but so I personally, that's one of the reasons why I prefer ABS. But it's a great filament. It's very strong. You know, it's very functional. So you want to print anything that's functional parts. It's great. Very popular as well. Very easy to get, and there's so many different versions of it. Third one, PETG. So if you ever wanted to print something that is flexible, you can use PETG, which is really great because you can, there are a lot of things you think about, like phone cases or like different applications where flexible is great. Props is also a great thing you can make, but there's a lot of practical things as well. There's other flexible filaments as well. PETG is the most popular though. Oh yeah, it's flexible when it's cooled. So like you print it into this object and it's cooled, and it's flexible once it's in a like solid state. You can't really tell when it's like in the filament form. Okay, there's something called wood infused PLA. So it's pretty cool. It'll be made up to like 40% wood. It looks like wood, and you can like finish and stain it, which is really awesome. The only issue you run into is it tends to jam nozzles. So what that means is sometimes you're extruding all this plastic through the nozzle. Sometimes things get stuck, and it's what's called a jam. And what that means is there's like something got stuck, or there's kind of like this plastic that's stuck there, and it won't print anymore basically. So you have to go in and you have to clean it out. It's kind of annoying. if you print right with it, it's really great. I haven't done it yet, but you can really make like things that look very much like wood, which is really awesome. Something called, so nylon carbon fiber. So it's saying here, you know, this is where you want ultra high strength. So this is like, you know, you're making something that is like combat ready, you know, very, very strong. It's very impressive. So to use this filament, you need a higher strength nozzle. I believe nozzles typically for FDMs are made out of, so nozzles is the little part where the plastic comes out. They're typically made out of copper, I think. And for this, you need a steel nozzle because this stuff is so like hard and abrasive that it like will wear away at the nozzle if you don't have something like steel. However, you know, the parts that you'll make with this are like most likely never going to break if you design it right. You know, it's very, very strong. So it's pretty cool what you can do with that. Okay, so U of R has some cool resources with 3D printing. For one, we have, for your robotics, we have a Creality CR10. It's a great printer. It's not technically ours, just as a caveat. It's UR makers, but we have a good relationship with them and they allow us to print things, which is nice. And same thing, this is more of a lower cost machine. In comparison to other 3D printing costs, it's not cheap. I think it's like $500-ish. But it's really great quality for that price in comparison to other printers on the market. Creality is just, I think it's a great brand. We also have a Stratus Uprint SE Plus, which is this thing on the bottom right. Yeah, it's an industrial quality machine reserved for ultra high strength parts. This is, you know, this is like you print, this is like, I think it's like $10,000. We're actually getting rid of this machine though, so this isn't as relevant anymore. But what you could do is, you know, this is a printer you'd have for like your company that you would, you know, that's printing like really high quality parts that it's like, try to be close to perfect, you know, it's pretty good. Also in the computer lab above Retner, there's a variety of 3D printers. You can pay to have them parts printed here, but you have a limited control on part print settings. That's basically, you know, you say, hey, I want this, and they'll print whatever file you have on hold per se. I haven't used the service yet, but you know, it should be good. Oh, sorry. Does anyone have any questions?
I actually just have a comment. Everyone, it's Bennett. So the club has PLA filament, and I wanted to ask, what filaments are these printers able to print? Like, does Jim have stuff for is it Stratus? What is available to us, I guess?
I believe the Stratus only prints in the Stratus only prints in ABS. I believe what they do is Stratus has like proprietary ABS cartridges, I believe. I'm not entirely sure. So yeah, like that. So there's kind of different calibers of printers. There's like the desktop printers where I will go out and I'll buy a roll of plastic and I'll stick it on there and I'll just set it to print and, you know, insert it in all this stuff. There's some printers that are like business printers that they sell these proprietary like containers of the filament, and they like you have to buy that specific. So like for the Stratus, it only prints ABS. I'm pretty sure. Does that answer your question, Ben? Okay, awesome.
Thank you.
Yep. Oh, I forgot to say that there's something also called PLA Plus, which I've been liking a lot very recently. PLA Plus is like a stronger PLA, but it's still like environmentally friendly, mostly. So I've been really liking that. I think it can be as strong as ABS if you do the right settings, which I think is really cool. Okay. Oh, sorry. So this is another important part. So I'm going to talk about STLs and slicers. You may have no clue what those are, but I will try my best to explain what they are because they're very critical to 3D printing. So in order to make something, you must first acquire an STL of that thing. So STL is a file type. And basically what that is it's a 3D file. It's a, like, you know how, so a lot of 3D objects you'll see are like they're .obj. So it's just like this thing that exists. Like you have like a ball or a pyramid, all this stuff. You can find so an STL, what it stands for is stereolithography. So it's like the most current and most popular file for 3D printing. And so let me explain what it is. I should have done this first. But so a STL represents the surface of a 3D body using points that form triangles. These triangles then connect and form the surface of the body. And you can vary the number of triangles created, which results in bigger/smaller files. I'm going to go to the next slide because I think it shows. Okay, yeah, this is great. So let's say you have a ball and you want to represent this ball in an STL. And let's say you made this ball in CAD and you can export CAD files in different formats. One of the things you do is STLs. So as you'll see, I have 3 objects here. They all kind of look like balls. The one on the right definitely looks like the most like a normal ball. The left one doesn't look that much like it. What's going on is the one on the left has a smaller number of triangles to represent the outside surface. And so the nice thing about it is the one on the left is much smaller file size. Like it's, you know, will take up much less space in your computer. And it'll be much easier to like modify things and like do anything you could want. The one on the right is more accurate. You'll see that it has a larger number of triangles. That's why it looks like a sphere, because, you know, when you have that many triangles representing the surface, it can look like much more like a sphere. So it might be hard to visualize sometimes why we do triangles. The only reason it's triangles is you're having these 3 points connect and you're forming a surface. And these surfaces all connect because you're forming all these other triangles. And that's how you get to like these shapes. And so instead of, if you were to export the ball as an object, it would be an even bigger file. So the whole reason we do any of this is because we just want that outside surface. That's all that matters to us. We don't care what's on the inside. We're just making this object that, we're just getting this object that has the triangle made up in it. So what's great is you don't always have to create these things on your own. There are a lot of great sites that provide the files to you. One of these sites is something called Thingiverse. I've been using this for probably 4 years now as well. It's a huge online library of 3D models. And on there, you'll find lots of, like, there's definitely hundreds of thousands of designs people put out. And you can search all these things and, like, make them. Just, you know, they're just out there. I will just sometimes go and find something that I think is cool, and I will, you know, go out and make it. One of the things, I don't know if you'll be able to see my camera, but like one of the things I made was this little screw container. You'll be able to maybe see that. And so I made like a little screw container. It's just fun, you know, cool things. And there's lots of these like cool knickknacks that's on there as well. But there's also lots of cool designs on there of like functional prints you can make. But when you go and you click on the whatever you want to make, you'll see that the file, when you go to there's like a files tab, you'll see that the file is STL, because same thing, that is the smallest, one of the smaller file sizes you can make. And what you'll get is it's much easier to download it faster and to upload it faster. That's the reason we use STLs. And also because STLs only represent the surface of an object. I went over this in my CAD workshop, but sometimes we want to represent objects as like these solid things, like an actual like cube filled with like mass and material. Other times we just want to say, I just want the outside of the cube. And so in this case, we just want the outside. That's all that matters, because we will decide how we want to print the inside, and the outside is the only thing that matters, like how it's actually shaped. That's why we use STLs. For us to mention, there's other alternatives like 3MF, but STL is much more popular than them. 3MF is arguably a better file type, but STL is much more popular. That's what you'll see anytime you go and try to find one. So you might just think, okay, now I have the file. Let me just go put it into the printer, and it should print something. Sadly, cannot do that. You have to use something called a slicer first. What a slicer does is it prepares your file. So it prepares what you want to print, basically. So a slicer takes your STL, and it said here, uses your settings to create a file which tells your printer how to print. We typically call this G code. So looking at the steps of the process, you have STL, the G code, and then put that into your printer and have that run. So as said here, it does this based on a variety of settings. So there's like, you can go and you can change 200 settings. There's probably like 5 that you really need to worry about at this moment. There's like movement speed, nozzle temperature, fan speed, and like infill. So movement speed is like how fast the printer will be moving, that extruder thing that moves the head. Nozzle temperature is what I was saying before, how hot you want the little end piece where the plastic goes through, how hot you want that to be. Fan speed is, hey, how much cooling do you want to go on? Because sometimes you want cooling. I'll talk about later on, which is layer height. That's like how tall each layer is going to be. If you have taller layers, the thing will be less precise. If you have smaller layers, it will be more precise, but it'll take longer. And then there's infill. So by definition, I didn't include it here, I probably should have, but infill by definition is how much of the inside of an object you want filled with stuff. So let's say you have a cube. You create the outside of the cube, but you don't want to fill the inside of the cube with complete plastic. It doesn't make much sense. It doesn't make the part better. It doesn't make it stronger. It doesn't make it anything. It just makes it heavier, and you're just kind of wasting plastic. Instead, what you do is you fill a percentage of it with plastic using different shapes and designs. So you can like 50% infill would mean 50% of it around 50% inside is air, around 50% is plastic. Typically, you can get away with a lot of starter prints of like, if you're not really want straight, you can get away with like 20% infill. So only 20% of it's filled with plastic. The other is just kind of holes that they're not structurally compromising holes. They don't need to be filled. But like 40 to 60 is a really good range for strength, or even 30 depending on what you're making. Does anyone have any questions? I know that was a lot, so I'm definitely can answer anything if you have anything. If there is no questions, I will go on. Okay, so Cura, as I was talking about before, Cura is a slicer. And I was talking before, slicers are very necessary. They're very useful. And Cura is a free one, and it's actually really great. I've been using it for, I don't know how long now, maybe a year and a half. It's a really great software, and it's pretty easy to use. So even if you've never used it before, I think it's pretty intuitive. And yeah, so I'm going to teach you a little bit like how to actually use it. So if you go to the site and download Cura. By the way, Cura is owned by Ultimaker. That was one of the printers I showed earlier. They own Cura because sometimes the 3D printing companies will make their own slicer software because you need both of them together. But it's great because Cura is free and anyone can have it even if you don't have an Ultimaker. But if you were to go to download Cura today, you'd be presented with this screen. So I'll show you kind of some of the steps you go through. So you have the screen, you have these kind of different things. At the top, you'll see the prepare, preview, monitor. Right now, we're just on the prepare stage. If you go to the top left, you'll see the little file icon. Here, you'll go in and you'll select your STL. So, I went on Thingiverse. I want to print this vase. I went and found the vase. I went to the files. I clicked. I downloaded the file. And now in my downloads, there's a vase1.stl. I go up there, I click, I select that, and I bring that in. In this case, I'll be using this hinge I designed for the CAD workshop. Or sorry, not a hinge. It's like this mount thing. It's very random. It has no use. It's just something I wanted to show off some of the features of CAD. Um, and so in this case, I have this mount. So I brought the mount in. This is just an STL. So I designed it in CAD. I exported it as STL. There's a little function in Fusion you can export. It's not that hard. And you have this STL, which is just a surface representation of this part using those little triangles. So you have all these things here. What you need to focus on is on the left, you can control a few things, and these are the most important. You can do size, position, angle, and a few other things. The most important thing you'll be able to see is when you click on it, all of these things on the left will become non-transparent, and you can move this around the print bed. You can make it bigger, you can make it smaller, you can mirror it around the axis. You can do all these cool little things. You can scale it up and down to like a percentage. So let's say I want this actually at 50% the actual size. You can make it really small. You do all these different things. Once you've done that, there's something in the bottom, something that says slice. So when you press this button, you're going to slice using the default settings. Because if you see in the top right, there's all these like little words and all this stuff. These are like your print settings. What I show here, I believe it's there. Okay, so it's later on. Basically, Cura defaults in the top right, and it just gives you like good settings to start off with. They're not the best, but they're pretty good. And if you were to press slice and you were to download that G code and put it on the printer, it'd probably come out fine. You know, the print would come out good. I'll talk more about like what you can do to make this better though. There's changes you can make. So once you press slice, you will be presented with your slice part. So you see how the part kind of looks weird now? The reason is because the slicer took that part and it said, I want to cut this into, you know, in this case, it's 450 layers. So basically what that means is you're having all these like little layers of the part. I'll show this real quick because I'm explaining it bad. This is a little GIF I took. It should run of like how this works. I might demo it live actually in a second just to showcase some of the more precise features per se. Okay, I'm gonna pull up Cura real quick. You should probably still see my screen. Just because I want to explain it in a more substantive way because I think that maybe what I was just currently describing might be a little confusing. I'll show through the slides real quick of what's saying here. What I showed here is you can scroll through these layers because as I was saying before, the fundamental aspect of 3D printing is you're taking this object and you're cutting into all these very, very, very small layers. And as I showed here in that GIF, you took this part and made it into all those things, the layers you can see. I'm gonna try to share my other screen. You should be able to see Cura now. Can people see that by chance? Or like?
Yes.
Okay, awesome, thank you. Okay, so this is the program I was talking about. There should be like, okay, so this is something I've been wanting to print for a little bit. It is a spring-loaded box. It's kind of interesting, kind of weird. This is something that I find interesting. So as I was saying before, on the left is all these different parts, or sorry, all these different controls I could do. So I can move this around anywhere I want. I can move it, you know, up here. I can move it up. There's no real use for that because, you know, you want to start the first layer on the ground. Then I can scale it. So I can go here, make it really big, or make it really small, or, you know, whatever I want to do. You can do it by percentage. You can rotate it. So like this, and just, you know, orient it whatever you want. You can mirror it. You can do these weird like overlap support stuff. These last two really aren't as useful. Those first four though are really useful. Okay, so what I was talking about before, and I'll make this as simple as possible. You have this part, and then you press slice. And what you'll see, as I've been trying to explain kind of somewhat incorrectly beforehand, is that the part, oh, sorry, my settings are really weird. Let me just put standard settings. The part will be reduced into lots of little layers. And what you'll be able to do is go and look at those little layers as individually. And what will pop up on the right will be that the layer view. Okay, so this little button says preview. And also, which is really nice, it gives you a time to complete. In the bottom right, you'll see 9 hours and 34 minutes. So using the current settings, the standard settings, which I just selected, it will take 9 hours and 34 minutes to print this. I also put in like filament settings. So like you'll see that filament is typically weighed is like, it is basically sold by weight. So you usually get like a 2 kilogram spool. And so you can see how much this print is going to use. It's going to use 65 kilograms. It's going to cost $1.69 because of how much I paid for that, the overall spool. Okay, so now let me show you this. And hopefully this, I hope it makes sense. So right now we're at the top, so we're here. But what I can do is go down and start at the beginning. So what the printer is going to do, it's going to get hot. The bed's going to get hot, the extruder is going to get hot, and it's going to draw out the shape. So this will be the first layer of the print. And this is 1 layer thick. So it does 1 layer. Then it says, okay, well, I'm done. I'm going to do the second layer. So it goes up. I might be able to pull it too. Yeah. So it does the second layer. And it does a little bit different. It's not that different, but just a little bit. And as you go on and go on and go on, you'll see that as time goes on, the style of the part changes. So maybe those first 20 layers it look like a certain thing, but as time goes on, you'll see that for this one in particular, it becomes walls. So as I was saying, the thing changes over time. You get to this point, and then what you'll see as time goes on is it changes again. It's no longer the same 2D cross section. Now it's becoming this weird shape. That's all the different things. So that is what the slicer is doing. So what the slicer says up top of the 360 is saying that it takes 360 layers to make this thing using my current settings. And same thing, this is using standard quality. There's like 500 different settings here that you can use. One of the most important ones you'll see is something called layer height. Layer height is how tall each layer is going to be. So if I were to, for example, I could also print in 0.12. If I do that, it's going to take longer to slice because, each layer is thinner. And so it's going to be, you'll need even more layers. It's going to take longer to print. However, it will be higher quality. What I mean by higher quality is that each layer will be, smoother. Instead of having like these thicker layers, it's going to be very smooth. But it's going to take longer, as I said before. I'll showcase this here real quick. See, before it took 9 hours, now it's taking 16 hours. And there's 600 layers. And so this is like the principle of 3D printing. It's like, how do you choose, like, should I use this many layers or this many layers or, whatever. And so you have to weigh that, More of what I'll say in a few minutes is that when you have smaller layer height, the part's also stronger, which is nice. Oh, so this is what I want to talk about, one thing, the infill. So you see these weird triangles that are popping up on the inside and there's like space here that there's nothing there? The reason is because the infill is that like It's at like 20%. I was saying before, 20% of the inside of this is plastic. The rest of it's air, because the rest of the, you don't really need the rest of the plastic to make the thing stronger, the part stronger. So that's why there's air. And you'll see that, you know, over time, these triangles change, and then they have, oh, sorry. Okay, so I think that is probably all I'm going to show with that. Yeah, I'm close to done. So if you have to, I don't want to run too far off of 9. Okay, so as I was saying before, there's all these different changes here. There's all these different settings, everything you can change and make and all this stuff. The same thing, I recommend sticking to the defaults. That's probably for the best. And what you'll see is online, there's all these different people that tell you, that say, hey, do these settings and your parts come out better. You go and you change them and you see if it does. Most likely it does, which is really nice because people have like done this before. As I said before, on the bottom, it has the estimated print time, the estimate of filament used, and weight, and all these different factors. And yeah, so there's a lot of stuff to change here, but if you stick to, you know, the basics and just start trying to print a few basic things, you'll start to get a feel of like what you can change and what's like really useful and like the most important things. So what I was talking about before, and that whole thing with the changing of settings, is that you can go through and change them one at a time. But what's really nice is that people, as I was saying before, they've come up and they said, okay, this setting works best for this printer. And so what they do is there's something called profiles. So Cura has profiles, which means they can export all of their settings and post them online. And then you can just download those really good settings and just load them onto your printer. So you don't have to mess with all these things. Because typically what will happen is a printer will have like a certain settings that work great with it. And so someone's already figured that out, and it's probably posted on the internet, so you can probably find it somewhere and just download it and run it, and you'll be good. And oh, as I say here, you know, what I'm describing here, figure out what settings you want to use, all this kind of stuff, that's like 95% of the process. You know, you're going to do this all the time. Just, yeah, experiment, find people that have already done this, and then, you know, find good profiles for your printer, whatever printer you're using. Does anyone have any questions? Sorry if I was a little all over the place as well. I was trying to explain something that's kind of complex. If there are no questions, I will move on. This should be the last section. So, you know, after this, yeah. So there are many features in CAD which will result in better 3D prints. There are many things you can do, you know, many improvements you can make. These, in my opinion, are the two biggest ones. And when you're designing something you want to print, and this is something that I try to always make sure is the case. One of the things you want to do is add a chamfer to the bottom edge of your part. And so what that does, and so sorry, if you missed the CAD workshop, I'll explain what chamfer is real quick. Basically, you put an angled edge on something. So you have like a 90-degree corner, and instead you connect it with a line and you make an angled edge. So you see here that it's just the bottom edge of that first part is now, you know, angled at 45 degrees. So the reason you want to do this is it makes your part easier to remove from the build plate. So when you get done and your part's finished, and an FDM printer is just sitting there, but it's like also kind of attached to the build plate depending on what material you used, or what, you know, all those different factors. But what you'll see is, you know, it gives you a little ledge to like scrape the part off if you need to really do that. Also, you'll prevent sharp edges on the bottom part because you don't want, you know, something that'll cut or anything like that. Most likely when it cut, it's just couldn't be sharp. So it's just a good thing to just do in general. I usually do like 1 millimeter chamfers on all my the bottoms of all my parts. The second thing is you want to round the bottom corners of your part using the fillet tool. And so what this results in is better adhesion between your part and the bed. The fillet tool adds a rounded corner. And you'll see in the bottom part, you can see in those two corners, the thing is rounded. Basically what that comes down to, and I'll explain this real quick, is that as you're printing something, and you're going layer by layer, so saying, you get to like 320 layers, that first layer has already cooled by the time you're moving on to the higher layers. So what happens when plastic, when plastic's hot, it's like nice and expanded. When it cools, it likes to shrink. And for everything you print, there'll be like some percentage of it shrinking. For PLA, it's like 3 to 5% shrink in volume. So it gets like 3 to 5% smaller than what you expected. And for ABS, it can be like 5 to 15%. And this happens once it's cool. So it's hot, and then it's cool, and then it gets smaller. That's just how plastic is. So it's just something you have to design around. But what it does is when that bottom layer cools, it wants to get closer to each other. So what it'll do is it starts to bend, and it bends up. So you no longer have, if you had like the square corners, everything wants to come together. And so what happens when you do the circular corners is it cools better, and you don't have something called warping. Warping is when the print comes off the bed, like it starts to cool, and because it's cooling, it's like shrinking. It's going to come off the bed on the edges, which really isn't good because then your print quality is, not good anymore. So those are my two biggest tips. So I recommend doing both of those for anything you'll design. This is what I was talking about before. As I was saying, as you decrease layer height, part strength increases significantly, but print time also increases significantly. So you have to weigh that, anytime you're deciding to print something. Another important point, that typically you want to orientate your parts to use as little support as possible. But, so you might ask what supports? Supports it's throwaway material that you use to build things that have a lot of overhang. Typically when you print something, you want it to like go just straight up. But if you're trying to print something that is, because I was talking about the layers, if you're trying to print over nothing, then the plastic will just fall. So what you have supports holds, you can print over an overhang, and it will be supported by that. So I'll show this here. This is a printing orientation tip. Printing orientation is a big thing as well, for strength. As I say here, a 3D print is usually weakest when force is applied parallel to its layer lines. So it's saying here, if you have a part that you print, like this rod that you print vertically, if you go and you try to snap it, it will most likely snap because you're applying force to those layer lines, and the layer to layer strength really isn't as strong as as the layer strength. So as you see here, if you make that same long flat rod, but you make it laying flat, it will be much harder to break because each layer is much stronger and wider, versus if you were to print it vertically. So yeah, you typically want to orient your object to print with the least number of layers possible for highest strength possible. So for example, I'm using the part from Workshop 2. This is one of the arms. So if you never see this will be the first time you see it. And basically, you might ask yourself like, okay, how would I print this? So I have these emojis to represent how I feel if we were to print it like this. You see that, or what you'd see, you wouldn't want to print it like this. You're gonna have a lot of layer lines. You're gonna have 750 layers lines. And so when you take the part off and you're done, for one thing, if you apply any force to that, it would depending on the material, if you're using PLA, if you apply a good amount of force, it would break around the layer lines. You'd also need those supports, because you can see there's things like at the bottom, if you look at at the bottom, that curve, there's like little plastic underneath there to support the part from like falling over and also being able to print it. And so there's a lot of bad things you wouldn't want here. The supports, the lots of layer lines, and then the not as strong. What you really want is this. You'd want to print something like this flat. because as I was saying, those flat lines are much stronger. This part's going to be much stronger. Like, I don't know the actual numerical value, but significantly stronger than the other example. Also, it would only be 25 layers, which is nice. And same thing, when force is applied, it'll take much longer to break. Oh, this is what I was talking about before with the SLA DLP, which is the resin based. You also want to orient your parts in this manner because the less layers you have, the better, basically, as I was saying before. Would print time be about the same? That's a good question, Bennett. So depending on the conditions and a lot of settings, it would vary. I'd say in this case, probably the flat one would be quicker. Well, it actually really depends. In this case, I think it would be relatively similar. However, there are certainly many objects where if you were to reorient it, it would take, maybe a fourth of the time, or it would take 4 times the time. It really depends on travel time. The travel time is the time that it takes to print something. Sorry, travel time is the time when you're moving from something you're printing to the other side to print. Sorry, let me explain this better. You'll typically sometimes have let's say you have 2 posts that you want to print and they're side by side. You will print the layer on one post and then you need to go over to the other post to print the layer on the other post. There's a time that it takes to travel between those 2 posts of the extruder head moving there. And so when you have that movement time and you do that over, however many layers, that results in a lot of time. And so with some, like if you orient something in a certain way, that isn't always the case, and it'll be much faster. In this case, might be relatively the same. So yeah, but still, I'd recommend printing flat. Yes. Oh, so this is how I printed the arms for the project on my Ender 3 Pro. I set it up just like this, and then I sent it off to Bennett to assemble. And as I said before, this required no supports, and the part is honestly really strong, which is really cool. And same thing. For this, I actually used like 20% infill, so 20% of it was filled with plastic, with 80% was air, which is actually still very strong. The 40 millimeters per second print speed, so that's how fast the nozzle moves as it's printing. The 60 bed, so 60 degrees Celsius bed, and then 205 degrees Celsius nozzle. So if you have any more questions, and if you ever get into 3D printing and you want to figure out stuff, these are 2 great sources. One is Simplify 3D's troubleshooting guide. I can probably, if I do a new share based on my screen, yeah. If I come here, this should pop up. Let me just see. I think this should pop up. Control click. Sorry. Basically, Simplify 3D's troubleshooting guide is you can go here, and if you print something, you can see visually what your problem is. So they have all these different problems you can run into with 3D printing, and they will physically show you what it looks like. And so if you don't even know what it's called, it has visual guides of all these problems. And you can go and fix them. They have all these different helpful things like, hey, you do this, you do this. One of the things I did want to show is, I think it has it here, is something called, where is it? Oh, warping. Okay, there we go. So you see how that corner is pulling up in this box? That corner is not touching the build plate anymore. It's not supposed to be like that. It's supposed to be touching the bottom. And that's what I was saying about the shrinking, is it shrinks, it likes to pull up on the corners. When you have those rounded edges, it doesn't do that as much, which is nice. Okay, so I literally have, so another great resource is 3D Printing Nerd. He's one of my favorite channels on YouTube. He does a lot of 3D printing tips and reviews and all these different things. There's a great community on YouTube and Facebook and all these different things of people that love 3D printing, and they're glad to help and all these different things. So he in particular is a great resource. Does anyone have any questions by chance?
Oh yeah, I missed the CAD workshop. I was wondering because I noticed you were recording. Do you have recordings of those?
So yes, for the first, well, I'll explain better. For the first workshop, we have the recording already posted on the CCC webpage for our workshops. It's the third link in the email I sent out, and you go there and if you scroll down, there's something, it says like the different workshop, and then to the right, it says link, and then you go there and it's YouTube video, has the entire workshop, first workshop. My friend Fran, she did the second how to actually CAD workshop. And she's still working on that. It should be posted within a day or so. And that will also be on YouTube, and it will be linked to it on that site. So you can go back and watch that video. I hope that answers your question.
Yeah, thank you.
Yep, no problem. I think I got a chat as well. Oh, yes. So thank you guys for coming to this. I have a few more things I want to say first. But this is like the little end slide. It should move. Oh, it doesn't. Oh, I have a little thing with 3D printing as well. I'll show it after. But so this is basically the end of the mechanical engineering side of this workshop series. The next three will be all based in computer science. And what I'll say, I put it in the email as well, is we'll be covering a lot of different things relating to computer science, things that I didn't know about myself, and different topics that are very interesting even to someone who's not in computer science. But if you're in computer science, it's also a great resource. So I'm going to pull up the GitHub real quick. Can you guys see this by chance?
Yep.
Okay, good. I'll explain it then, and then you can probably follow up. Basically, this is one of the things I linked in the email. The GitHub is where will be most of the files for the next workshop are. The next workshop is Intro to Programming, so we're going to go through like how to use Python and all these different other cool things. But all like the instructions, everything you want to know is here. I'm very excited for it personally. I think it's going to be very cool, and I hope you guys all show up. Bennett, do you want to say anything?
Yeah, I'll be leading, the next workshop and I think the two following. And we actually have some setup to do for the first workshop, or for next week's workshop. If you click on if you click on Intro to Programming there, actually, it'll show this. This is linked in the email as well, but basically there's like list of setup steps for Windows or for Mac. This will take you through kind of doing a couple things that are useful for the workshops. For one, like where we're going to write the code. Let's install maybe an IDE to do that. Let's use the command line to download the code. And then you set up some stuff with Python to make sure you can run Python code. Doing this before the workshop is of course useful, so that during the workshop we can cover like what were the commands that we used, and of course actually testing and writing Python code somewhat live. But of course, the point of these workshops is for you to be able to do these things and learn Python in this way if you'd like. So by installing, by following these steps, you'll be able to run the code on your machine. You'll be able to both use the demos that exist and like edit the demos in a way that I think is meaningful. So we have like coding exercises for each of the following workshops as well to, go in and test kind of understanding Python in a couple different ways, as well as some of the algorithms later on. So please do that setup. There's also office hours sometime next week that's mentioned in the email. You can also drop a message on Discord if you run into any problems, but the setup process should be pretty quick, assuming it does work.
Okay, yeah, thank you, Bennett. And yeah, same thing I'll say is that it might seem daunting, like, oh my God, I've never done computer science before. I don't have much experience either. Like I did Java in high school, but like other than that, I have not done any of this kind of stuff. But like I think the next workshops are really great for people who are not have not typically done these kind of things. But I think there's also a lot to be learned for someone who's maybe already in computer science as well. I think it strikes a nice balance. So yeah, I highly recommend you show up to that. Try to think what else. Yeah, just yeah. Thank you guys for coming. I very much appreciate that. I think that's it. So yeah, thank you for your time, and yeah, I hope maybe I'll see you next time as well. And yeah, Ben had posted the link there. Yeah.
Also, please do not use any of the code for any assignments you have. We give a full implementation of A-star. That's maybe the one thing that's useful elsewhere. So we're
Yes.
trusting that is going to be used appropriately. Yeah.
Yes. Nice. Okay, yeah, I think that's it. So yeah, thank you guys. Thanks for your time.
Hey, I have another question. I
Mhm.
was wondering, the 3D printers, do they, how do they do with like multiple different filaments at the same time? Like say an object has requires multiple different materials, but like for different sections of the part, like let's say it's one big object, but one part needs metal and another part needs plastic. How do they do in terms of like working together, or is it usually just like one big object that's all one material?
So typically what you'll run into is with your specific example, typically with the metal and plastic, you'd have to do that separately. However, there's something really cool. You can get printers that have multiple nozzles, which is really cool because you can print with multiple materials at the same time. It's pretty impressive. Basically, what you do is you have a spool on one side of one filament and a spool on the other side of the other filament, and you can like make multicolored objects or objects with different properties. Like you could do like magnetic or anything like that. And the other cool thing is that there's so many options of like filaments you could use. Typically, though, you'll print in one material though.
Oh, good. Thank
Yeah.
you.
Yep, no problem. Hope that helps.